Hello everyone, this is How I Love Geometry. I'm Mr. Cao. This problem is from Introduction to Geometry. The problem says the lengths indicated on the rectangle shown are in centimeters. So this is a rectangle, right? And this side is 8, this side also 8, this is 14, this also 14. And in numbers, what is the number of square centimeters in the area of the shaded region? So it let us to find the area of this part, right? So these two segments split the total rectangle into 4 parts, 1, 2, 3, 4. So you see it looks like symmetry, right? This is 5, this is also 5, this is 9, this is also 9, and this is 6, and this is also 6, this is 2, and this is 2. We want to find the area of this one. So it looks like symmetry, right? But the intersection point I, it looks like this is the center of this rectangle, but we should prove this one. Yeah, main idea, how to find the area of this part, right? It looks like a little complicated. So we know to find the area of this part, we just erase then we will find this one, the area of this one. So if we connect, because this, if we connect HG and EF, so this triangle EBF, also right triangle, and EBF GDH, so they are congruent, right? This is a right triangle, this side congruent to this side, and this side congruent to this side. So these two right triangles are congruent. It means this angle and this angle the same, they're congruent also, and HG also congruent, equals EF. So now if we want to prove this is the midpoint, we need to know this triangle and this triangle, I mean IGH and IEF should be congruent. If we want to we know this vertical angle, no problem. We know this side congruent to this side. We want to know another angles, because we not easy to know. At this time we don't know GI equals IE, or you can get some information about HI and FI. So we should try to find the area, because this angle congruent equals to this angle, and we know because DC, right? This is DC, parallel to this AB. DC parallel, it means what? This angle equals this angle, right? We know that's interior alternative angles, and also this angle congruent to this angle. So this angle must be equals to this angle. Now we got AAS. So triangle IGH congruent to the triangle IEF. So this side must be congruent to equals to this side. Also, we know this equals to this, right? So now the problem becomes easier. This point I is the center, or in the middle bisector not just GE, also bisect HF. So it means if we connect GF and HE, this one, so EFGH now is on this side. We know GF also equals G, and we know this triangle, this. So it's easily to know this is a parallelogram. So the parallelogram, this part, the area for this part, I mean the area for the GIF is just one-fourth of EFGH. And now the problem is easy. We just find the area for this part, this. So GFC, the area for the GFC equals 1/2 times 2 times 9, so equals 9. And this is 1/4 of this parallelogram. So we just find the area for EFGH. EFGH equals the total area. Total area is 14 times 8, right? And minus the area of 2 of this one. So we know 1 is 9, so 9 times 2. And the area 2 of this triangle, so we know 1/2 times 5 times 6, now 2 is 30. So that's the area for EFGH, and we need 1/4 of them. So this is 132 plus 112 minus 48. So if we just need 1/4 of that, so GIF equals to what? That's divided by 4, 112 divided by 4 minus 48 divided by 4. So that's 28 minus 12, so equals 16, right? 112 divided by 4 divided by 4. So what we want, the area, the shaded part, area GIFC, the L for this part equals to which one? 9 plus this 16, so 25. Yeah, we find the area of this one. But what I want to say for this problem, it means it's not just one way to solve this one. That's not one way. Another way we can get the area for this one. So we can do from pass through I, we can get, if we know this is the center of this rectangle, now the problem is easy. And from I, right, to IJ, right? And we know the area, we can get this part, this right triangle, plus this is a trapezoid. So IJ is how much? IJ is 1/2 of this CB. So that's 8. So this is 4. I mean IJ is 4. Equals 4. And GJ, because total is 14. And this is 5. Here is 1/2 of that. So this is 2. So the area of for GJI, this part GJI, that's 1/2 times 2 times 4, that's 4, right? And the area for this trapezoid IJCF, we know is 1/2 times, this is 2 plus 4, then times the height is how much? Now is 7, right? This half of that. So that's 6 1/2, that's 3 times 7, 21. So the area we want to get 21 plus 4, also 25, right? That's another way. So this we can call is V1 and V2. This part is V2. And also, if we come here, we know that we can also to got this one, right? J, if this is K, so we can easily to find the area of this, and we can use, yeah, just find 1/4 of that, like we can just cut it into 4, all of the area is the same, and added this one minus this one is the same. Also, here I want to introduce, if we not easily to find at the beginning, this is the center of this one, of the rectangle. So how to solve this one? Also we have the way, of course. This is 5, also 5. This is 2, also 2, right? So 2, 6, 9, 5, also 5. Yes, this is 9 and 2 and 6. So this is I think we can easily to think about to find use shoelace theorem. Shoelace theorem we can use, of course we know the coordinate system at the beginning. We define the coordinate system here. This is the original point, so we know the coordinate of this point is, so here is E, right? And when is x is 9, 1 is 0, and so here is G, and this is A, B, C, D, and E, here is F, G, here is H, and this, when x is 5 and y is 8, right? X is 5, here you see, here is 5, this is 9. So we find the point of this and the point of this one, and the coordinate of this point, x is 0, y is 2, and x is 14, right? 9, and y is 6. Here we see 6. Now we can find the intersection point of this I, the coordinate of this one, because we can easily to write the equation of this GE, this line, or we can say this segment. So we know the slope of this one, 8 minus 0 over, this is 5 minus this 9. So negative 4, so is negative 2. Now, the equation line, we can use this one. Y minus this 0 equals, slope is negative 2, x minus 9. So we know that's 18 minus 2x, right? That's the equation of the GE. And we can easily to also write the equation of this HF. So the slope of this one, this is y over this y minus this y, that y, 6 minus 2 over 14 minus this 0. So that's 4 over 14, so it's 2 over 7. Now we will use this point, and this is the slope, and y minus 2 minus this 2 equals the slope 2 over 7 times x minus this 0. So y equals 2/7 x plus 2. Now we want to find the intersection point of I. We just solve the equation. This one equals this one. So 18 minus 2x equals which one? 27x plus 2. So 16 equals 2x plus 2 sevenths x equals 16 over 7x. So each side divided by 16. This is 1, this is 1. Each side times 7 times 7. So we got 7 and 7, x equals 7. So this is the middle point, right? X equals 7, and the y, we can easily to find the y here. Or you can get 7, y is here. 7 times this 7. Then reduced, then 2 plus 2, so y equals 4. That means I coordinate is 7 and 4. That's the middle point of the x coordinate and the y coordinate is the center of this. So if we got the center of this one, if we know, we can use shoelace to find the area of this polygon, right? Everyone knows, right? And then all of them, for here is 4 points. The coordinate we write down here, and then use the shoelace theorem. Also, if we know, it means we have proved I is the center of this rectangle. We can use the same way we just used here, right? Just find this one, this part plus this trapezoid, or we can use this one and this one, and a lot of ways to solve, even when we know I is the middle point of GE, also the middle point of HF. Bisect these two segments. Okay, I just explain. I say here, stop it here is okay, because this problem is not so hard, but I just show you one geometry problem. Sometimes we can find a lot of different ways to solve it. I believe this problem must also have another different ways to solve it. Yeah, I hope you enjoyed. Thank you. See you next video.